let's go ahead and start. Again, I would like you guys to go to Article 2. Is it working with that one? Okay, so that just doesn't work with it. 210. If you guys go to Article 210, that would be great. Article 210, that talks about branch circuits. When it comes to branch circuits, a couple of things we're going to talk. Determine the number of branch circuits for a set of loads. There are three types of branch circuits you're going to be encountering in every commercial building. Anybody can tell me the first one? Right above you, yeah, receptacle branch circuits, lighting branch circuits, and equipment. Yeah, equipment branch circuits. See, these are the three types of branch circuits that we're going to be encountering. When we do branch circuits, guys, I have a couple of things I want to share with you as we move on. We never ever grab, well, not ever, but when you grab a panel like this, you don't bring two conductors in a half-an-inch EMP conduit and pull them for the receptacles. I hope you don't do that. We group them. When it comes to the branch circuit, there's something called grouping. The one who did electrical work, you understand fully how we group circuits. All 20 amp circuits, you will be fooled not to group all your 20 amp circuits in 1 3/4 inch conduits as you get them out of the panel into a junction box, and then you spread them right through your building, right? You don't want to put a half-an-inch EMP conduit out of this panel for every single branch circuit you have. You'll have tons of EMP conduits. Grouping. So we get into grouping. Why grouping? Because it's economical to group multiple circuits into a one conduit as you get them out of the panel into the ceiling, so you can spread them to feed the lights and the receptacle. If your wiring methods is conduit, if your wiring methods is MC cable, it will be in a commercial building. It will be very beneficial for you to use a 3-phase cables, meaning you can carry 3 circuits with a neutral in one cable. So at least you can't carry more than that, but you can, I guess. But the typical, if you're using cables, at least 3-phase cables. So you can carry 3 circuits, 20 amp circuits, and a common neutral with MC cable. So who cares? Who cares if you group them together? What happens when you group carrying conductors? You get into the rating. So that's why we get into correcting factor as appropriate, adjustment factor. So that's what I want you to understand. First, we have receptacle branch circuits, lighting branch circuits, and we have equipment branch circuits. Then we group them as they come out of the conduit. We group them together, and I have a presentation for you guys. We'll do the whole grouping and the rating. And then we apply the rating factor to it. That's it. Then we're going to talk about motors. When we have a branch circuit for a motor, you guys have done it with me last quarter and this quarter. What do we do? It's continuous load. What do you do with it? 1.25. So continuous load. And the same thing, overcurrent. Every branch circuit must start and end with an overcurrent protection device. Every branch circuit must start and end with an overcurrent protection device. Let me see if I can grab that one here. And maybe it will work. No, today the PowerPoint presentation is not. So you have to size the overcurrent protection device for this branch circuit too. You have to size the overcurrent protection device for the branch circuit. So we have a conductor and an overcurrent protection device for every branch circuit. So we'll talk about this one for a second. Then, when it comes to branch circuits, guys, and I'm sure you have seen them many times, time and again. When it comes to branch circuits, a few rules that you have to keep in mind. And I'm going to wait, since my pen is not working with the PowerPoint presentation. I'm just going to draw a branch circuit and show you the most important thing in this branch circuit that you're going to be encountering. So here's your branch circuit. Let's put the 3 types of branch circuits that dear to my heart and dear to yours. Here's my panel, and I'm going to show the branch circuit number 1. Here's my 20 amp branch circuit. Right out of this, I have receptacles, and I have receptacles. So this will be my receptacle branch circuit, right? Here's my number 1. I'm going to go right in here, and I'm going to have another branch circuit, and these guys, I'm going to call them lights, LLL. This will be another 20 amp circuit, and what do you think this circuit will be? Number 2, this will be a lighting branch circuit. Cool? Anybody has an issue with that? And the third one, I want to have an equipment So all the way equipment, and that will be typically 20 amp circuit for equipment, smaller equipment, or higher, or higher, and that will be my my equipment ground, my equipment branch circuit. So that's my number 3. Any comments, guys, about these branch circuits? All coming from the panel. The most important thing that you have to understand, this is all coming from one single fat panel. Now, you will be full to take, let me just talk about this. How many conductors do we need to carry 20 amp circuits in a conduit? 2. So here's my conductors. 2 conductors, number what? 12, thank you. How about here? In a commercial building, number 14 dropped immediately. You don't use 14. So how many conductors do I need here? 2 conductors, number what? 12. Now, suppose I have a piece of equipment and it's a 20 amp dedicated circuit for it. So that would be also 2 conductors, number 12. So 12, these are, so what I want to bring to your attention, guys, is number 1, for every branch circuit, you need an overconduction device, as we all know. For every branch circuit, you need a conductor or conductors or cables to carry the branch circuit current. And then at the end, you have to terminate the branch circuit at the utilization equipment, which is a loop. Cool. So these are the branch circuits that you need to be encountering, most of the branch circuits. So moving forward, Adam, my friend, we will not pull slower than 20 amp branch circuit on lighting. Can I have a thumbs up, Chad, for that one? That's what we're going to be pulling. Okay, so this chapter is all about 2 things. Number 1 is going to talk about an overconduction device for the branch circuit. So that's number 1. Number 2, the conductor. That's number 2, right? So the overconduction device and the conductor. And number 3 is how many of these we can put in them. Right? How many receptacles can I put on a 20 amp circuit? How many lights can I put on a 20 amp circuit? Cool. How many equipments can I put in a 20 amp circuit? What are the rule of thumb for engineers? What's the best practice for doing that? Cool. Does that make sense? Any comments, guys, about these branch circuits? Remember, the feeders and the service, I think we did a lot of stuff on that one. Okay, so just keep this in mind, guys. Now, the second thing I want you to understand, take this. Here's a panel. Can you guys see that panel? I want to bring these. How many circuits do I have? Right so far, I have 3 circuits. Just by looking at that, 3 circuits. The best way of working, the best way of moving in a 3-phase system, the best way to do your branch circuits in a 3-phase system is to move in 3-phase, to move in 3-phase. For example, so I have receptacle here. So I'm going to go, this is from phase A. This will be 3, now that's no. This is going to be 3 circuit breakers, 20 amp each. Cool? 3 circuit breakers, 20 amp each. And how many conductors? So it's going to look something like this. 1, 2, 3, coming down. And here's my neutral coming with them. And how many conductors this will be then? 4 conductors, number what? Number 4. And 4 conductors, number 12, right? 4 conductors, number 12. Cool. So imagine this is the way you move in a commercial 3-phase building. You don't move with single conductor with single circuit breaker. You move with 3-pole circuit breakers or 3 single-pole circuit breakers tied together with an approved handle. That's what they call it. Multi-wire branch circuit. So I got multi-wire branch circuit for the receptacle. I'm going to have another also 3 here. Why do you guys think 3? Another 3 multi-wire branch circuit here. For the equipment, typically will be 3 because most of the equipment, bigger equipment in a commercial building, 3-phase anyway. Heaters and so forth, there will be 3-phase. So that will also be 3, okay? But what I'm getting to is when you get all these, so let's just say, so I have, when I move it this way, I have 4 conductors, number 12 here, and I have 4 conductors, number 12 here, and I have 4 conductors, number 12 here, right? 4, 4, 4. With me so far? 4 conductors, number 12, assuming we need a neutral. How many conductors total of number 12 do I have? 4, 4, 4, 4. 12 conductors, number 12. Now, Zach, you're the designer. You're going to design the system. You're going to lay it out. When you get out of the panel right here, do you think you're going to take three conduits for each one of these? Or are you going to group them together in one conduit? Group them together. That's where the derating becomes a big deal. So here's how, coming out of there, here's how it's going to look like is when you come out of the panel, inside the conduit, you're going to have the following conductors. You're going to have, how many did we say? 12. You're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So right in here, you're going to have 12 conductors, number 12, EWG done. Inside, typically we move with a 3/4 of an inch EMT. You're moving with 3/4 of an inch EMT conduit. Inside this conduit. Now, what's the problem? Derating. What's the problem? Now we need to derate, right? If this is a multi-wire branch circuit feeding lights, if it's a multi-wire branch circuit, guys, feeding lights, does the neutral count if it's a multi-wire branch circuit feeding lights? Does the neutral count? Yes, the neutral is going to be carrying harmonic and it will count. So take this. I have 3 circuits feeding lights. All these conductors are carrying current. I have also 4 conductors going for an equipment with the neutral. Let's just assume the neutral also is going to carry current. And I have receptacle here feeding harmonic loads like your laptop. And these are all carrying current. So how many carrying conductors do I have? I could have. I know some of it might be plus or minus 1 or 2. How many could I have? 12. So when you have 12 conductors carrying current, what's going to happen to number 12? The amp of number 12. You need to derate. You need to derate, right? You need to derate. So keep in mind when you do commercial building, you need to derate. Let me tell you one little fact about number 12 in particular. If you take number 12, guys, so let's just go to a different page. So I'm going to take number 12 because I'm using number 12. AWG THHN. If you take this boy to 310.15 B16 under 90-degree column, you are going to get 30 amps. Right? If you guys go there, you're going to get 30 amps. Cool? You're going to get 30 amps. 30 amps out of this conductor. Right? Now, that's under 90 degree for derating. So, how many conductors do we have? So we have 12 conductors, number 12, all carrying current. If you take this one to which table that derate? You guys remember the derating table? 310 dot. If you guys go to 310.15 B3A, this will be 310.15 B3A. B3A. These are tables. If you guys take 12 conductors, number 12, to this table, what's the derating factor? For 12, 10 to 20, 50%. 50%. Cool? Are you guys with me? 50%? Everybody's okay with that? 50%? Okay, so now let's see. So that's how much that guy can carry. That's how much you have to do it. Moving forward, so you take the 30 amps, multiply it by 0.5, 50%. What do you get? 15 amps. 15 amps. You get 15 amps out of this circuit. You get 15 amps to use. Okay? Can you guys see where the 15 amps come? Now, some of you are mad now. Well, okay, here's the 20 amp circuit. 20 amp circuit. And these per conductor, right? Oh, per conductor. Yep, absolutely. Here's my light. How much current you can get out of this branch circuit continuously? How much current you can get out of this branch circuit continuously? Continuously 80% of the rating of the circuit breaker. So you're limited to 16 amps anyway here. You're limited continuously to 16 amps. On a 20 amp circuit, continuously, you're limited to 16 amps. You can't take more than 16 amps out of 20, right? Because you can't pull more than 80% of a circuit breaker continuously, like lights. So take this. So after I grouped them all together, Darren, how many amps did I lose? 1 amp. Does that make sense why we group them all the time and we don't worry too much about losing a lot of amps because of grouping? After you group 12 of them together, You only lost how many amps? 1 amp. Because you can't load continuously at 20 amp circuit more than 80% of its rating. 80% of 20 is what? 16. So that's the number that I personally use when I size for lighting circuits, 15 amps. Assume that 20 amp circuit will be carrying 15, and that's how you size how many circuits you can, how many lights you can pull from a 20 amp circuit. How many lights you can pull from a 20 amp circuit. Okay, so keep this in mind, guys, as we go through. This is very important. I have a couple of others I'll show you. But before we move on, so that's what I wanted to show you guys. The minimum circuit, conductor, and so forth. So when it comes to branch circuits, we have 3 branch circuits. We have receptacle, we have lights, and we have equipment, and we group them. Any conductor number 12 or smaller, it will be fool not to group these conductors together. And when you group them, you still have enough juice out in the circuit, right? You still have enough juice like we've just proven.
Did you take the 90 degrees just because you're not going to overrate the
We took the 90 degrees because for derating, you use 90 degree. That's why they give you THHN, guys, for 90 degrees. Because when you derate, you start with the very high amps. After you cut, you're going to end up with some type of a reasonable amount of amps. Thank you. Okay. Okay, so that's conductor selection. So when we thought circuit will have long uninterrupted life. So a couple of things, guys, for conductor selection. So the first thing is continuous load. Temperature, if the temperature is different, you have also to derate based on temperature. And also voltage drop. This particular one will talk about voltage drop, selecting based on voltage drop. So you have to take into consideration voltage drop. We will be doing voltage drop calculation for branch circuit pairs. So why it's a big deal for branch circuits, like I showed you at number 12, you do not want to exceed what the conductor can carry under maximum, the capacity of a conductor defined as a maximum continuous current that the conductor can carry under its specified condition. Like we said, so the maximum for number 12 under the conditions that we put it in was what? 15 amps. 15 amps. When you select a conductor, and some of this stuff, guys, is a review for you. When you select the conductor, the first thing you select is the insulation. If you're doing conductors inside the building, your insulation is going to be THHI, right? If you're selecting conductor for outside, your conductors will be THW. Done. So the insulation. So from the insulation, guys, also the size will determine the resistivity. And that's also determine the voltage drop. So when we size them, we have to take into consideration voltage drop. How far can I take a 20 amp circuit away from this panel without exceeding the 3% or the 2% in this case branch circuit of voltage drop? That's a big deal. So sometimes when you hear me, Darren, telling you that don't put more than 17 fixtures on 120 amp circuit. Say, are you kidding me, Chad? But keep in mind, when you don't want to put more than 17 fixture, for example, on one circuit or 18, you're going to take into consideration the voltage drop. You're going to take into consideration grouping them together and continuous load. 3 things you have to take into consideration when you size a circuit. That's why when you guys get into engineering firms, you can find them. They throw a lot of circuits. You know, every 20 fixtures, they throw a 20 amp circuit, even though you could have put another 20 fixtures on the same circuit. Voltage drop is a big deal, so keep this one into consideration. Okay, so the insulation, of course, all conductors have to be insulated. When it comes to insulation, there are 2 types of insulation, guys, you're familiar with. The notoriously famous one is THHN, thermoplastic. This one can soften when it's heated and get so soften when it's heated. That's why we use it in indoor. But the problem with this one, it stiffens for cold weather. That's why you don't want to put it outdoor. For cold weather, stiffens and cracks. So that's why we jump into the ones that best insulation for basically the hot and cold weather is going to be RHH. So this is just a few things about I want to emphasize the high and low temperature. If you have an R in it, that's why they use these RHH guys and RHW. They use them for fire pumps and so forth, the insulation. Most of us will be living right here. THHN/THW, done. That's where you're going to be living. But just a few differences between the T for the thermoplastic and the R for the thermoset here. The difference between them is the one that has an R is good for higher temperature and lower temperature. The one for the T is good only for higher temperature and lower temperature. It stiffens at cold temperature. Anyway, so what we're going to be using here inside the building is what? What type of conductor? THHM. If we go outside, what type of conductor are we going to be using? Any conductor that has a W in it. Can I use RHH inside the building? Yes. You shouldn't use it. A little bit more expensive, right? It's a better conductor insulation. Not needed really, except for a certain application. So why do we use THHN? The most affordable, economical conductor that you can use indoor. When it comes to wire selection, guys, you are familiar with 310.15B16. I hope by now you have two options for brand circuits, copper and aluminum. 90% of the time, when it comes to brand circuit, you are dealing with copper. Feeders and services, you probably would say if it's engineered project, it's copper. Feeders and service could a lot of times becomes aluminum because of cheap. But brand circuits, you get into brand circuits dedicated to the equipment, you're talking about 90% of them, unless the brand circuit is a big brand circuit, 100 amp brand circuit, you're dealing with copper only. Difference between copper and aluminum, guys, you guys know that one. Copper can carry more current, more expensive. Aluminum can carry less current, but light in weight. If a weight is an issue, aluminum becomes superior. What weight is an issue, aluminum becomes superior. Something like this. Yep. Something like this. Yep. They're conductors. Conductor insulation with multiple. There's a lot. We talked about this one, I think, yesterday, guys. A lot of contractors carry a conductor that has THHN/THW. One insulation. So you don't have to carry two types of wires. THHN/THW, you can use it outside or you can use it inside. Any comments, guys, about the insulation? So THHN/THW, the double insulated, probably your perfect world because you can use them outside, inside. And copper is your perfect world. Wet location. All these locations require you to have an insulation that has a W in it, rated for wet location. If you have raceways in direct contact with earth, any place where there's basically wet location, any wet location. Good example, outdoor cables or raceways, underground cables or raceways, car washing areas where it's always flooded. So these are your conduit of location where you have to use a wet. So you have to be wet locations. We size them definitely based on 310.15B16 as we have just done that. I'll get into that one in a second here. I always say when I talk about conductor, guys, I said enemy number one of electricity is heat. If you don't care about smoke coming out of the insulation of a conductor, you can make a number 14 carry 50 amps, right? You don't care about the insulation melting and smoking. So that's why excessive heat will destroy your insulation. That's why the NEC code book do a couple of things. Number one, limit the amount of current that the conductor can carry. And number two, if you put it in a higher temperature, what do? You degrade again. So it's all about not allowing the conductor to carry more temperature than it can handle under that specific condition. Meaning inside the conduit with other conductors or in a very high temperature, higher than 30 degrees Celsius, or on a roof of a building where it could be cooked by direct heat and indirect heat, the whole derating stuff that we talked about. So that's why all these guys talks about the whole ambient temperature and applying ambient temperature for covered conductors, and we will do some of these. If you have conduits on a roof, you have to also derate based on how high the conduits are set on a roof of a building. Why? Because if you put a conduit on a commercial roof, guys, it's all about heat. There are two things. Number one, the ambient temperature. Number two, there's direct heat coming in and indirect heat coming out from the roof. So they will be cooked more than if they were not on a roof. So the Smarter Than Chad decided that it's about time that we allow more derating if we are to put a conductor inside a conduit on a roof. Cool? The table that deals with this one, 310.15b3c, values for to add temperature if you are to put a conduit on a roof. If you're to put a conduit on a roof. And I will go through a couple of calculation examples, guys, with you, just a refresher. Just be aware of that one. We'll go a couple of examples. Ambient temperature and heat derating, they call them penalties or derating. So long story short, your conductor that's supposed to carry this amount of amps, if you put it in a different higher temperature than what's rated for, or if you group it with other carrying conductors more than 3, or if you put it in a roof, that amount of amps that's supposed to carry, it will go down, as we know. Why? Overheating conductor. Heat is the enemy number one of your conductor. Here's an example of grouping. Grouping conductors for 20 more than 24 inch, longer than 24 requires you to derate, as we all know. There's a couple of exceptions for the derating, and I'm sure, I don't know, probably you guys know, Darren and Jeff. If you have a conduit, here's that conduit. This is a conduit carrying current. If 10 feet, if not more than 10 feet or 10% of the length of the conduit is in a higher temperature, then you can apply the lower temperature ampacity. So for example, suppose the conduit gets into this room, very high temperature, then leaves to the other room, very low temperature, right? So which temperature are you going to use, right? Typically, the high temperature you use except. The high temperature you're going to use except. Here's one exception. Permits a higher ampacity if the length of the conductors that enter the higher temperature is not more than 10 feet. So take this there. I came in with only 9 feet, and I got out with 100 feet. So what do you think I'm going to do? The higher. So 10 feet or 10% of the total circuit length. 10%. What's 10% of 100 feet? 10 feet. Or so there are two things. Either 10 feet or 10% of the circuit, because the circuit could be 1,000 feet. 1,000 feet. If 10 feet out of the 1,000 feet are in a hot temperature, you have to derate. If that makes sense. So length of the conductor enters the temperature is not more than 10 feet or not more than 10% of the length of the circuit. Okay, that's what you can derate. So summary, guys. You have to derate for a couple of locations. If you group, you have to derate. If you put them in a conduit more than 24 inches, you have to derate. If you put the cables, cable assembly run together more than 24, not separated more than 24 inches, also you have to derate. You'll see a picture of that one. Okay, so figure we'll talk about this one. Another thing when it comes to branch circuits, guys, very, very important as for inductive heat. What do you do for phase A, phase B, phase C, and a neutral in a multi-wire branch circuit? Do you put them in the same cable or conduit? I hope so, yeah. What happens if you put cable branch circuit phase A in one conduit, phase B in another conduit? What do you get? You get inductive heat. So almost always, we're going to group all the conductors of the feeder or branch circuit in the same conduit. So keep this in mind. This talks about the continuous load, guys, which is your size based on 125%. I will go through the calculation with you. We'll talk about all these in abbreviations, guys. Okay, so this is where this book talks about I think this is one of the best, you guys know this one, but this is one of the best tables that I've seen that talks about overcapacity device. For example, what happens if you have a continuous load and you need to size a conductor? You multiply it by what? 125%. We all know that, right? So minimum, not less. So conductor size 125, overcapacity device 125, you go to next standard, right? How about if you have an HVAC equipment? You guys have done with me HVAC equipment. the conductors will be not smaller than the minimum circuit ampacity on it, which is 1.25 times the rated load amp. And the overconduction device will be stated on that piece of equipment. It will be stated on it, the overconduction device. If it's non-continuous, not less than the load and not less than the load, both of them, non-continuous. You can, if it's non-continuous load, guys, you can load a 20 amp circuit up to 20 amp circuit. Why? Because they're not going to be running for 3 hours or more fully loaded. If you have a motor, you guys remember what we did for motors? 125 amp for the conductors. For the overconduction device, it varies. If you remember when we used fuse or circuit breakers, so it says it varies. Cord and plug connected, not less than the overconduction device. Rating, ampacity, and not less than the load, not less than the load. So really the most important ones are the first three: continuous, HVAC equipment, non-continuous, and motors. And we have done with the residential guys a bunch of these circuits here and there, and I will group them in one example as we move on, one calculation. So now when you lay out your receptacles, guys, with me, starting next week or the week after, you're going to start laying out your receptacles and your lights. What do you need to do with them? You're going to group in the branch circuits. How many branch circuits? How many receptacles in a branch circuit? That's what we're going to answer. How many lights in a branch circuit? That's what we're going to answer. And then when you group them based on lights are continuous load. I'm telling you right now, lights are continuous load. So can you load a 20 amp circuit more than 16 amps? No. So you're from the get-go, you're limited to 16 amps. Because we group them, always group them together. Remember that calculation that we did? So you can't pull more than 15 amps. So you are looking at 15 amps out of 20 amp circuit. That's your limit on lights. On receptacles, guys, we have a limit. The other limit on receptacles we'll go over is 180 volt amp for all the receptacles. They are non-continuous load, but we have a factor that I give you, an engineering factor that cuts them actually almost by half. Here's a fun thing. You can take the volt amps of the lighting volt amps of your building, divide it by the voltage, and divide it by 20, and that will get you how many approximately lighting circuits you need for this building. One more time. You take the volt amp of your lighting panel, divide it by 120, because lights are burning at 120, divide it by 20 amps, divided by 20 amps, and that will get you the number of branch circuits that you need. So that's what this goes. Now I can't emphasize, if it's continuous load, you're always limited on the branch circuits to what? 20 amps. You're always limited to 20 amps. Here's what I tell you guys, for convenience, different arrangement can happen. I could, for example, parking lot guys, parking lot lights, you don't want to mix them with the indoor lights. Can you mix them based on the code? Yes. Should you mix them? No, not a good idea. So if I have a parking lot, and it's a good idea to group them in 1 or 2 circuits and put them together. Outside light on the perimeter of building, I could easily pull them with the interior light. Is it a good design idea? No. It's a good idea to group all the perimeter lights, put them in one branch circuit or multiple branch circuits, depending on how many of them. So that's where that goes. Determine branch circuit, verify conductor. So this is how you do it. Determine the number of circuits and load per circuit, the overconduction device, and verify the conductor size. And I'll go over an example, guys, that explain all this. Let me show you a couple of things that's really pictures here. The rest of them is, okay, where did that go? Okay, the first thing I want to say, guys, if you are, Carrie, my friend, if you're feeding your rooftop units like this with a conduit inside a wire in there, what do you need to do to the wire? Derate. You need to derate more temperature. Why? Because it's in the roof, it's going to be cooked by the roof, the heat coming direct and an indirect heat. So this is an example of where you have to pay attention to the rating temperature of the conductors. These are cables. This is really cool. Ampacity of cables, if you longer than 24 inches, without maintaining separation. If you don't separate them for longer than 24 inches, you have to also derate them. Derate, look at this one. If it's LM cable, if it's MC cable, derate for every 20, only 20. This is for, so take this. You have a group of MC cable all grouped together, lump sum, right? Like this for 10 feet. They will 10 feet, grouped, lump sum and lump sum. You have to go derate if these group of cable, MC cable, have more than 20 carrying conductors. So what would that force you as a designer? To spread them, move them away from each other. Don't group them, don't lump sum them like this.
How far away do they have to be from each other? 6 inches?
Typically, think of a diameter, typically a diameter of the cable, so a size of a cable. So here's cable 1, size of a cable, cable 2. You separate them, then in a case like this, you don't have to derate. But remember how many carrying conductor you can? You can carry 20 amps, exceeding 20 amps, you start grouping them. Exceeding 20 amps, you start grouping them. So that's for MC cable. If it's a conduit, of course, 24 inches or more. This is when you do branch circuits. The most confusing things is when you do branch circuits, multi-wire branch circuits. I'm going to put my switches here. Here's a switch for this light. Here's a switch for this light, and here's another light here. And I'm going to grab another phase here and feeding this light and bringing it like this. This is Aaron, my friend, and Kerry, and Jeff, and I'm going to put a switch here. This is exactly how you're going to be wiring. This is exactly how you're going to be wiring lights in a commercial building. Multi-wire branch circuit. You're going to take, let's just start with phase A, phase B, phase C, and a neutral. Phase A, B, C, and a neutral. And this is my light here, another light. Now, if each one of them is carrying 10 amps, as we all know, this is carrying a 10 amp. Each one of them is carrying a 10 amp. What do you think the neutral is going to be carrying? Non-harmonic. 0. If this switch is off, you open this, right? There's a switch here. If you open the switch here, then you end up with this situation, right? So the amps here turn into what? This amp is off, so I have 0 amp. What do you think the neutral is going to carry? 10 amps. So be very careful. That's why when we size a neutral, we size it based on in a branch circuit, not feeder, not service. We size it based on the worst scenario. Because I have 3 circuits coming in here. If I turn one set of lights off, now the neutral is going to carry the full current of the other 2 circuits. One of the other 2 circuits. Any comments, guys? Any questions about these multi-wire branch circuits?
It's getting more common to ditch the multi-wire branch circuits and just pull neutrals from the circuit because nobody wants to have to cut 3 circuits to
Tied together in one
circuit.
I can't agree more. I'm an engineer, so pull as many conductors as you want. So
Just that, you know,
On the wire.
Yeah.
A lot of circuits are just getting their own neutral pull.
yeah.
After the code change, they stopped doing that because
Yeah.
now everything has to have handle ties or we have 3-pole breakers.
Yeah.
You know,
But here's my argument. I hear you. Actually, engineers specify a neutral because of harmonic on certain loads. We specify a neutral with every circuit. But take this. If it's not specified multi-wire branch circuit, no question asked. Now here's my question is, how often do you really have a ground fault in a lighting circuit?
Well, I think it's more of a maintenance. You know, because if you turn off the circuit, you don't want to have to turn off.
So you have to turn off all of them. Yep. Yeah, I can agree. If you have to work on them. Now, having said that, what happened in 2008 when the NEC code book came with disconnect switch for double-ended fluorescent lamps? Why do you think the NEC code book came with 2 things? Number 1, multi-wire branch circuit have to be tied together. With that came a disconnect for that fixture, exactly to solve this problem. Now, by code, this fixture above your head has to have a disconnect within sight. So I can actually, in this case, I don't have to have a disconnect. If I have multiple levels of lights, I can turn this set off and go work on it. That will be that qualifies the disconnect. Or what the industry standard, guys, is a little plug that you can plug and unplug to disconnect the ballast. Any ballasted equipment.
Everything's simple that, huh?
Yeah, that's a standard. So that, see what I mean? From a maintenance point of view, this solves the problem with the most dangerous ones, which is ballasted double-ended fluorescent, because these are the ones that cause troubles. So that's anyway, but that's kind of my but it's a lot of engineers still, believe me, specify engineering project that we did, we specify neutral, whatever phase. But so then in a case like this, then you have to have a neutral coming with, as you can see, with every one of these phases going to the fixture. Any comments, guys? Any questions? Any comments? Any questions about that? So that's your fixture. This is one of my favorites. This is from 310.14. You guys remember these rules? We wrote these rules before in 2000 when we talked about the commercial. We said when we size conductor equipment, if it's 100 amp or less, or the conductor number 14 through 1, it's defaulted to 60 degree, unless they tell you otherwise. This is coming directly from 110.14c. 110.14c. Very, very interesting. So I have a 60. It's 100 amp, and the size is the default. UL default for these equipment is what? 60 degree. UL is 60 degree column. If you go conductor higher temperature, you can use a conductor with higher temperature. The conductor can be higher temperature. Can you guys see the conductor can be higher temperature? But the ampacity have to be based on 60 here and based on 60 here, 60 column, degree column. Now, if the logs, the NEC code book says higher than 100 amp or more than number 1, you always default it to a 75, then your conductor 75, then based on this, your 75 degree column is your default. So for motors, I don't know if you guys remember, for motors, we said motors always define, for motors, we define the 75 degree column. Do you guys remember these rules that we did? Yes, sir.
So the third one, 75, that's above 100 amps?
The third one is, above 100 amps or more than number 1. Or no more than number 1. Unless, can I use the word unless you know otherwise? That's the default from 110.14, unless you know otherwise. So these are the rules for the terminals. When it comes to the commercial building, guys, when it comes to the commercial, we're going to assume all the lights, all the equipment are rated for 75. If you have a three-phase system, it's a good assumption. Here's the rule that you just talked about here, right here. If the conductor is over 100 and over 1, you will default to a 75. Default to 75. Everybody understand this rule, guys? 100 or less, or conductor number 14 to 1, you default to 60. More than 100 or more than number 1, you default to 75. Therein, unless you know otherwise. Unless you know otherwise. Then if the logs are rated based on this rule, then I can use any conductor in between them. So the smart person will use the THHN conductor so he can get the highest amps out of it. The highest amps. So conductor higher temperature you can use, but you have to look, for example, here, the logs in this side and in this side are rated for 75, and I'm using a 90 degree THHN, THHN. When I size this conductor, which column do you think I should go to? I have a conductor 90, lugs both sides 75. Which conductor should I go to? 75, thank you. 75. 75 degrees. Any comments, any questions about this, guys? Any comments, any questions? Now I'm going to change this one for you. If that one was 60, now the conductor has to be sized for what? The weakest link. What's the weakest link? 60. So this is going to be sized for what? 60 degree column. 60 degree column. Any comments, any questions about that? Straightforward. Can I have thumbs up, Chad? We understand this one. If I test you guys, if I could give you a quiz right now, would you get it? Yes, no?
Mine must have was up on the last test.
On the last test. So these are the most important ones. When it comes to commercial building, guys, the assumption is three-phase equipment. Zach assumed all 75. You have a three-phase equipment, you always assume the lugs are 75. You have single-phase equipment, then you apply the rule. If it's single-phase equipment, 100 or more, 75, less than 100, 60. That's kind of my rule of thumb. But if you have a three-phase equipment, you have a heater, three-phase heater, and 50 amps. Definitely, the assumption is it's a three-phase. What's the assumption? It's 75, almost always. Okay, here's your load. Because of harmonic, that's exactly what you said, fluorescent light. Because of harmonic, guys, we'll talk about harmonic. Look at this scenario. I have 10 lights here, and 10 lights here, and 10 lights here, right? 10 lights. Each one of these lights are, so 10 lights, each one of them is carrying 1 amp. Each one of them is carrying 1 amp for a total of 10 amps. So if it's fluorescent lights with the ballast, the neutral will be carrying double the same amount. Can you guys see that? I have a 10 amps here, 10 amps here, 10 amps here. Why do you think the neutral here is carrying 10 amps? Not zero. Harmonics. Harmonics. When you solve the problem of harmonic, there is 3 ways of solving the problem of harmonic. This problem can be solved in 3 ways. Way number 1 is what Jeff just said. Chad, I'm going to go pull a neutral with every one of these boys, right? And color it in. Okay, so there will be 1 circuit, 2 circuits, 3 circuits. That's solution number 1 for this problem, right? A neutral with every circuit. Cool? A neutral with every circuit. So that will solve this problem. Now, solution number 2 is to make all the conductors the same size, stay as is, and if this is number 12, and this is number 12, and this is number 12, and this is number 12, does it? Who cares if the neutral is carrying 10 amps? Right? Look at this. Who cares if the neutral is carrying 10 amps? It's already rated for 16 amps continuous. So who cares if the neutral is carrying 10 amps here? So I can stay as is. Who cares? The neutral is carrying 10 amps. Who cares, right? Who cares? It's already rated to carry 16 amps. So I can actually stay as is, or I can pull a neutral with every circuit. That's an option. A third option we use in an industrial building, guys, is they take this neutral and they make it number 10. AWG. They make it number 10, so they make the neutral bigger. They make the neutral bigger. So that's a few solutions to solve the problem of harmonics. A lot of engineering firms, what they do is they pull neutral with every phase. But if you know that this is the load, this is your load, your circuit is load, everything is rated for number 12, who cares if it's carrying 10 amps? It's already rated for 10 amps. Any comments, guys? Any questions about this issue? Okay, so we don't talk about the single phase system here. This is if you know, guys, if in a single phase or 3 phase, if it's in a single phase system, you take 10 and 15, it adds up to 5, right? If that was a 3-phase system, what do you think this will be? What would the neutral be if it's 3-phase system? The neutral will be 15. The higher. Well, it has to be rated for the higher if it's 3-phase system. We solve this problem, guys, by basically pulling full neutral all the branch circuits. All this will be solved. Okay, branch circuit dedicated for motors. The only thing I want to see, and we did a lot of calculation for these when we size these, 1.25 times what? Full load current, right? Continuous load, 1.25 dedicated circuit, and done. Short runs, couple of calculations. Here's a nice graphic of what the circuits are that we use, branch circuits. This is really interesting. I want to start with a lighting circuit. I have a lighting circuit, a 30 amp lighting circuit, that's feeding all these lights, and this conductor will be number 1. If you have a 30 amp circuit, what conductor should you be using? What conductor? Kerry, what conductor would you use with number 10? With number 30? I said the answer. You said it. Number 10. Okay. Can I use a higher than number 10 conductor, number 8? Yes. Where would you use things like this? Parking lot is a good example of that one. In a building, typically we don't use more than 20 amp lighting circuit. Okay, so heaters. Heaters, I have a conductor rated for 40 amps and I'm breaking it at 30. Is this okay? Is it okay if the conductor rated for 40 amps and overconduction? Yeah, no problem. Same thing here. I have a conductor, a motor. I have a conductor rated for 20 amps and overconduction device is rated for 30. Is this okay and why?
You have inner strength motor.
So is it okay? Yes, it's motors. Motors are an exception because of the air rush. That's where a lot of people guys get confused. They go in the field, they come, Chad, you can't believe what I see, what I saw. What did you see? I saw a number 12 conductor tied to a 30 amp circuit breaker. Okay, no problem. What's at the end of that conductor? A motor. What do you think with the motor here? Don't we have, most of motors have overload protection. So that overload protection at the end will protect the cable from overload. So that circuit breaker is protecting you only from what? Short circuit and ground fault. So that is the exception. This one here is the exception where you don't have to, the conductor does not have to match the overconduction device or be larger. Huh? Yeah, the conductor, well, it's about heat as well as about short circuit. Short circuit, they're protected from overconduction device, which is coming typically heat. It heats up. There's the overload here will take care of business. The overload will take care of business. Okay, there's a few, this table, guys, that we'll be using. It talks about the THHN, NEC code where THHN is rated for 90. I hope everybody knows it by now. Where all these insulation, where you can use them. This is directly from the NEC code book, right in here. 310.104a, it will tell you why did Chad keep talking about THHN and THW. THHN and THW. So this is the 310.16. You guys are familiar with 310.16. The rating factors. This is your derating factor from table 310.15b for table 310.15b16. Everybody knows how to use this table, right? We'll have an example about it, but everybody knows how to use it. This is your derating table based on bundling the conductors. That's what I just said when the example that I used. We use 50%, right? Based on this table, bundling more than 3 conductors in one conduit. This is the table that you can use from the NEC code book, guys, if you put a conduit in a roof. So if you put a conduit in a roof and you put it at 12 inches, you have to add an ambient temperature of 30, right? So you put 12 inches, you're going to add an ambient temperature of 30. So our ambient temperature in Minneapolis is 90 degrees Fahrenheit. And I'm going to add another 30 degrees Fahrenheit. My ambient now is 120 degrees Fahrenheit. Does that make sense how to use this table? You add more temperature. If you put the conductors, here's my roof, and I put my conduit. This will be, what is it, more than, above 12 inches. Above 12 inches, okay, between 3.5 all the way to 12, right? This is 3.5 to 12. So I'm going to put them up to 12, and I put my conduits here on the roof, and I put my conductors in it, right? That's how you apply this. Any comments, guys? Any questions?
So basically, it can be a conductor conduit too.
This is for conduits only.
For some reason, I was thinking raceway for the whole time.
This is for circular raceways. Circular raceways are conduits. For the most part, they're conduits. Yeah, they're conduits. Now, non-circular raceways So that will be surface mounted raceways like these one. These are raceways, but they changed in 2011 to these will not apply to, right? These are non-circular raceways. It applies. Can you guys see the word circular raceways that they added? You're almost limiting this to what? Conduits. If it says raceways only, then it applies to a raceway that looks like this too.
Is it the gray, is that's not raceway?
That's a raceway, but it's not a circular raceway.
No, is this a raceway?
They make a raceway that looks like this.
Cable tray?
Yeah.
No.
No, not cable tray. Does not apply to cable tray. A circular raceway, guys, is 99.99 is a conduit, EMT, rigid, PVC, any conduit. A couple of things, guys, about the devices. You have to pay attention to the lugs in your device. If it says aluminum, aluminum only, cover aluminum, that's probably for a lot of electricians to do that. We talked about this one. This is the one I'm going to spend, and then I'm going to let you guys go. And hopefully, Joe will be here to talk about this. This is how they size the branch circuit in this book. Can I just get you guys to pay a little bit of attention to this, please? One little thing. Because when you read this and do the example, it's not rockets. We've done it. It's not rocket science. But let me just tell you what they did. They took, there's a style eye fixtures. All these are fixtures like the ones above your head. Style eye. There's 17 of them. How many of them? 17. When they're in 27. Why did they say 17? 27. There's 27 of them. When Darren designed this building, he put 27 of them. What's the volt amp? The volt amp in each fixture is given. Load volt amp is given as what? 61. So this number then, this number here, is these two numbers multiplied by each other. Take the 27. Can you see that? Adam, my friend. 27 multiplied by 61. I might have to start giving quizzes, guys. 27 times 61. You multiply them. Here's what you get. If it's C stands for, so that's the answer. C stands for continuous load. So what do you do if it's continuous load? You multiply again by 1.25, right? Piece of cake, and that's what you get. Does that make sense? You take the number of fixtures multiplied by the volt amp of each fixture, multiplied by, this is continuous load, multiplied by 1.25, we will get this number. Any question up to this point, you guys will do it all the time with me when we size, right? The volt amp. Then, correction factor. Correction factor. Now the question would be, do I have to derate? Do I have to, it's one circuit, do I have to derate for this circuit? No derating, no ambient temperature. So this one, no derating, ambient temperature. Number of conductors are 2, no derating. Number of conductors are 2. Adjustment factor is nothing. Total amps, the total amps here is this number, guys, divided by 120. Can you guys, if you take 6, if you take this number, oh, this is not the ambient temperature, I'm sorry. The ambient temperature, this is the ambient temperature. If you take this number, I don't think we have the total. If you take 1647 multiplied by 1.25, divide this by 120. Can you guys, can somebody do that and tell me if you can come up with 17.2?
Yes.
Okay. So the ambient temperature, my apology, the ambient temperature is actually the same. So no, the ambient temperature, we don't have temperature to read. Okay, so it's 17.2. Okay, so for 17.2, my friends, my conductor sizes will be what? Number 12, I already took into consideration the continuous, and the overconduction device is going to be what? 20 amp. So you're looking at a 20 amp circuit with number 12 conductor, two number 12 conductor that feeds lights. How many lights? 27 lights. Each one of them is 61 volt amp. And the circuit number is circuit number 1. That's how they did the circuiting for this project. Yes, sir.
How you don't put 16 amps on?
Good point. Very good point. Okay. Very good point. Let's take this number. Take this number, 1647 divided by 120. Can somebody do that for me? Take the 1647 divided by 120. How much? 13.7 amps. Darren, is the 13.7 amps more than 16 amps? No. So remember, this is the actual load. We up it 25%, and then we size a conductor. We did it instead of, you know what I mean?
20% of 80.
As, absolutely.
Just
Reversing the 80%. Reversing the 80%. You don't compare this number with the 16. You compare it with the actual load. Okay? And so this is what they did, guys, here. They took all these fixtures and they assigned 1.25. For example, this fixture is an emergency fixture. Since it's not going to be on at the same time, they call it non-continuous load. They took the number, this number, and basically they assigned a 20 amp. Can you see that they even look at, this is my favorite. Here's a 20 amp circuit here. 20 volt amp. Can you see this is only 20 volt amp? Can you see that they assigned a 20 amp circuit for it? Regardless, for a 20 volt amp, they assigned a 20 amp circuit for it. Regardless of for emergency circuit, just for that load. Any comments, any questions? So that's for all, that's how they calculated the branch circuits. When we calculate branch circuits, guys, we calculate based on 3 calculations. I do this for the master exam prep all the time. You calculate it based continuous load, you calculate based on the rating, and you calculate based on voltage drop. And you choose the one that gets you the largest conductor. That's what they're trying to mix here. Here in particular, they're trying to mix only the rating and the continuous load. The rating and the continuous load. And if you look at the bottom here, before my friend comes here, if you guys look at the bottom of this table, this is what they did, guys, for the heater. Can you guys see the heater here? I have my heater. I have one heater. Here's the amount. Multiply by 1, give you this continuous load. Then divided by 120, you come at 26. The next standard overcome protection device is 30, and the overcome protection device is 10. Make sense? They're not no rocket science, really. Air conditioning. Here's the amount of the air conditioning. It's hermetic motors, 1.25. And then you size it, it's a 53.1 amps. Number 6 based on 75 degree because 3-phase. And the overcome protection device for that one is 60 amps. Okay, so any question, guys, about this table? Because there is an example, homework that you have to do it based on this. I can't emphasize, if it says C, it's continuous. If it's N, if it's H, it's heating and cooling and ventilation. If it's R, is receptacle. And if it's N, is non-electric doors, non-continuous. So these are the type of the loads that you're going to have: continuous, non-continuous, receptacle, or light. Light, which is continuous. So motors, which is really going back, guys, to receptacle lights and equivalents. Receptacle lights and equivalents. Any comments, any questions? Any comments, guys, about this table? Any questions? That's how they use this table. Lump sum them. I can't emphasize. I'm going to write them down here, guys. When you size branch circuits, you have to size them. So branch circuits, sizing. There's a 3 calculation you have to do. Number 1 is continuous, if it's continuous. Continuous, what do? 1.25 times the I, and you go size it. Number 2, derating, and that could be for temperature, temp, or could be for bundling. And number 3, which we haven't done, is voltage drop. This is how we do in a commercial building sizing a conductor, based on 3 things. So take this. If the first calculation came up with number 12, The second calculation came up with number 10. The third calculation came up with number 8. Which conductor should I be using for this branch circuit? Number 8. Notoriously famous Adam example of this, parking lot. You do a parking lot, you size based on continuous load, it will tell you number 12. But the parking lot is a long distance. You're going to end up with the 120 that you're going to send there. You might end up with 90 volt at the end of the parking lot. That fixture is not going to lit, right? It's not going to go on. So because of that, with voltage drop calculation, I might end up with a bigger size conductor. Can I get you guys to understand these three things? Really, everything that I talked about revolve around these three things. We haven't done voltage drop calculation. We will be doing it. What we did today is these two. So when you size based on continuous load or the rating, you choose the one that gets you the largest conductor. The largest conductor. The one that gets you the largest conductor. Any comments, guys? Any questions? What I'm going to do with you, I hope Joe will be here, guys, today. What I'm going to do, guys, tomorrow, I'm going to take these, I'm going to size them, size branch circuit, different branch circuits. Oh, yeah, different Joe. Any question, guys, about branch circuits? I can't emphasize when it comes to commercial building, guys, the smallest branch circuit that you want to use is what? 1 amp. That's your minimum branch circuit that you're going to be using for a commercial building, 1 amp. Okay, that's what I have. Thank you.